Hi, may I know who is this who's accessing this DSQB account?
Hi, Sanatan. Good morning. This is Praisiti.
Can you please confirm whether this
Ye-
link has been shared with the
Yeah,
students?
yeah, I'm checking that. Give me
Yeah,
two minutes.
thank you. Because it was shared with me today morning at 5 a.m. So I'm not sure.
Okay, give me 2 minutes. I'm
Yeah,
checking that.
yeah, take your time. Hey, hi everyone.
Hello, Santan.
Hi. Did you receive the link just now or?
Yeah, just now I've made a phone call to the peoples,
Oh,
but yeah,
okay. I received it in the morning at 5 o'clock.
we haven't received like any mails or something. I was
Okay.
continuously refreshing the page, then only I found the link now.
Oh, that's fine. Okay, let's wait for maybe 2 more minutes. Hopefully others also join in.
Usually they'll upload it. Still in the Zen class, it shows that the class schedule was not updated, but while I was
It
refreshing,
would
it
have been
shows they
updated just
joined
now. I
class.
actually messaged these people and asked them
Oh,
just to
okay.
check because I received it in 5 o'clock, right? So since nobody was there at 9, so I presumed, okay, it's maybe not shared with the students at all.
Okay, just now it was updated,
Just
yes.
now, I think probably it was done.
So we were getting into NLP today.
Yes, we are starting in LP. Let's wait for maybe 1 or 2 more minutes so that others also join in.
Sure, Santan.
Meanwhile, if you have any questions or anyone else has any questions, we can discuss.
We got our second project, Santan, the phone papers.
Phone papers, okay.
Yeah.
You to build a dashboard, I think, in that
Yeah, we have to build a dashboard and then we need to provide the
and deploy it on
10
Streamlit,
drop
I
downs to the
think.
users. Yeah, I had some doubts. Like they said, we need to use the MySQL only. So that just now I've dropped an email and then I spoke to an coordinator and he said you can use Postgre or MySQL as per your wish.
Okay, let's start. It's already 9:06. I don't think others will join in, or maybe they're not aware. Okay, that's fine. So, see, NLP is the domain where we deal with. I think we have already given like the motivation behind it. So, it's a domain where we work with human readable text. So it's a language that we speak. So language could be Hindi, English, Japanese, Spanish. So any language that we are compatible with. If we are processing any of those data sets which involves human language, we will say that we are working in the domain of NLP. Okay. So NLTK is a library for NLP, a natural language toolkit. I will show you the power of NLTK in just a few minutes. But let's first maybe analyze, say, a small data set, and then we will see, okay, how NLTK kind of is the boss in comparison to if you would have done, say, basic pre-processing. So NLTK gives you a lot of tools which can make your life super easy. But let's try to compare it with something that we would have done if this NLTK was not around. Okay, so have you seen the movies dataset before? The IMDb movies dataset?
No.
No? Okay. So I'm going to pick this dataset. You can download it from Kaggle, or I can upload it for you in the Drive folder. Okay, I'll do that as well. Okay, so let's load this dataset. I think I have it on my desktop right now. This is just a sample dataset. So okay, we can pick, if you want, I have a Twitter dataset as well where we have tweets. Okay, so we can pick that also. There is no limit. Okay, I mean, there are thousands of datasets which are available. I picked it because I think people love movies. They love watching cinema. So let's go with this. Or maybe in some other class, we will do some other dataset. Okay, this is a data set. This data set is about 1,000 movies. So I'm showing you the first 5 movies. So as you can see, you have the rank of the movie. These movies are the top 1,000 movies. Rank 1 indicates the highest rated movie. I think this was collected in 2018. When this data set was collected, this was the best movie on IMDb at that. Back then. It tells you the genre of the movie, some description, like 3-4 line descriptions, sometimes 2 lines, sometimes 1 line only, the director of the movie, the actors, year, maybe say runtime, rating, votes, revenue in crores, and Metascore. Okay. Metascore is like the critic score. Okay. So we have a total of, I think, 1,000 movies in this data set. Yeah, 1,000 movies, and each movie is described by these 12 characteristics: rank, title, genre, description, director, and so on. Okay. So, okay, can you think of certain tasks that you want to do? Can you think of certain tasks? Let's say, given this data set to you, what is it that you want to figure out?
Looking at the description, I want to know to which genre the movie belongs to.
Okay, looking at the description, you want to know, okay, if the genre is like what set of genres are there? That is what one task is. Okay, so can I say this is multi-output classification?
Yes.
Okay, because each output would be a binary classifier, right?
Yes.
Okay. Because for each genre, you would have to say, okay, if it is yes or no. Okay, so maybe say the genre, predict the genre from the movie description. Okay, what else? I'll try to do some of these today, okay. Or maybe all of them if time permits. Okay, anything else that comes to your mind?
Based on the rating revenue.
Okay, based on the rating, we can predict the revenue. Okay, why not? We can include other features also.
Yes. Scope.
Okay. Not just on the rating, right? Rating is something that is given afterwards. I mean, I can just use the the title, genre, description, director, actors, in which year it came, the movie runtime, and I can predict all of these things, right? The last 4 things, if you think about it.
Yes.
Okay. So basically predicting all these things, rating, votes, Metascore. Okay. So based on say the movie characteristics. We can predict, say, the revenue, rating, Metascore. Okay, so this becomes again a multi-output regression task. Okay. Okay. Anything else? Think of simple data analysis. Let's say, what kind of data analysis would you do on this?
Which genre of movies like receives more rating and preferred?
All right. So, which genre is rated highly? Okay. You can think in terms of the profit. Okay. All right. Anything else that comes to mind? We can do all these things. Okay. It's not going to take much time. Okay. All right. Anything else? So
Which
let's generalize it. Whatever you want, just tell me. I'll try to do this today. Okay. Can you think of maybe say which actor is present in the top 1,000 movies?
Yes.
Okay. So which is the most celebrated actor? Or the set of actors, let's say. Okay. Who are the most celebrated actors? Okay, anything else?
Which director has more?
More impact in the top 1,000 movies, like the
Yes.
most, the you can say the well-received director.
Yes,
Okay.
based on the revenue.
Appreciated director. Okay.
Yeah, well
Okay.
appreciated director.
Okay. All right. Anything else comes to mind?
Which actor prefers which genre of movie? Like comedy actors are
That we can do. So basically, for each genre, we can see what actors are there. Okay. Actors corresponding actors. All right. Okay. Is this enough? Just for a head start?
yes.
Okay. Because these things are actually quite simple. But we will see. Okay, we will see. So I will try to do these easy things first, and then we will move on to difficult things. Which one do you want me, or which one do you think is the most easy thing?
Well appreciated directors.
Okay, let's say well appreciated director. So we just have to see which director is coming the most, right?
Yeah.
Okay. I mean, you can think in terms of say revenue and all that, but let's try to see, okay, which director is coming the most in say the top 1,000 movies. Okay. So we have these DF of directors. Okay, this is my directors. Okay, these are my directors. Now, let me see. Okay, let me see. I'm not sure whether these directors are like, is there only one director or are there multiple directors? I'm not sure. Okay, but so okay, let me try this. So what I'll do is there a possibility there might be multiple directors? Doesn't seem like it, right?
You can see if there is a comma in the director field that
Yeah, I can do that. Okay, so no, but then I have to print everything. Okay, let's see.
after splitting we'll get a list, and if we have length of list as
Yeah,
two,
have to. Yeah, that is what I'm doing. So doesn't seem like it, right?
yes.
So only there is one director per. Okay, only there is one director per. I should say, let's say greater than one, because there might be more than one, right? No, right? Because there might be more than two directors. Otherwise, that would have been faulty, right? Okay, this seems all right. So I presume there is only one director. Yeah. Okay, all right. So once I've checked this, okay, I'm pretty sure, okay, there is nothing. So what I'll do now is, okay, once again, okay, I'll just see this. I just have to be sure. Okay, it's printing, right? All right. Okay, so what we have right now is the directors. So I have to, create a separate column for a director, right? Does it make sense?
Yes.
I have to create a separate column for a director. So what I'll be doing is I'll be using, say, transaction encoder or the count vectorizer. So you can use transaction encoder, or which one do you want me to use? Transaction encoder we have already seen. Shall we do that?
Yes.
Because I have to convert this data to structured, right? So for each, you can say unique director, I have to have a column, if you think about it. So if the director is present, it would be a 1, otherwise it would be a 0. And then I can simply sum up for all the directors. Does it make sense?
Yes.
Okay. So I'm going to use this transaction encoder. Let's do that. So e-processing. Let's take this transaction encoder. Set it to your data. So transaction encoder requires your array of lists. Okay, so this is my array of lists. And I can transform this. Okay. So it does it. So if it's present, it's a true, otherwise it's a false. Okay, I can convert it to int. Okay, and these are the unique columns. So columns underscore. Okay. Amir Khan directed which movie? Maybe Tare Zameen Par. Okay, let's see. Well, it's also there in the top 1000 back then. Okay, good for him. All right, so this is your data, and these are your column names. Okay, make sense? Yes, people. Is this clear?
Yes.
Okay, so this I'll call it encoded directors data frame. Okay. Okay, this is my encoded directors data frame. So there are 644 unique directors. Okay, so there will be very less appreciated directors. 1,000 movies we have. Let's see which director is coming, say, twice. I think it would be either Christopher Nolan, if I don't remember if he was doing movies back then, because this data set is like 5 years old. Okay, let's see. So I'm going to compute the sum of this encoded underscore dir underscore df. I'm going to do the sum of this at axis equal to 0. I want for each director. Now there is this Adam McKay. Okay, and I want to find the maximum. Let's see what is the maximum. It's 8. Oh, somebody has directed 8 movies. Okay, let's see who that actor is. Okay, I think I can do argmax. It's 518. Okay, so this would be the 518th column. So this is the director. Okay, encoded director data frame dot columns, and this would be the 518th director. Does it make sense? Oh, Ridley Scott, very famous, the creator of Batman. Okay, so this is the director that is like pretty famous. Let's see what other movies he has made. Okay, so this is a director, the most famous director. If you want, we can sort that as well. Okay, so this is the most famous director. Let's take this. Okay, and are you able to follow me, or am I just doing things quickly? Yes, people, are you able to follow me?
Can I not simply do unique np dot unique of that column and return the counts for each value of the column?
I didn't get you. Like, can I?
First I get the unique values in the director column of the
Unique values in the director column, yes.
and return count. So that will give me
Why have I done it this way? You are right that we could have done it that also. Okay. Why have I done it this way? Because every time you have to think in the sense for NP unique, right?
yes.
Okay. Now there is only one director. What if you had data where you had multiple directors. So there are co-directors also, right?
Mhm.
Okay, that's why I've done it this way. But you're right. We'll do it that way also.
First
we'll
we'll
do-
split, and then that each that we got on that list we can do NP unique and
For sure. We will do that also. We'll do that also. Let's say this is method 1. Okay. Let's call this as method 1. Okay. There are so many ways. So yours is actually more appropriate right now. I would put it like that because there is only one director per movie. Okay, let's see. Okay, so this was the list, and let's say if I want to find out the most, the highly rated directors, I can sort this by. I can sort these values. Okay, just a second. I'm doing the sum, right? Will it allow me to sort because there is no column as such? I think I can still do this. I can say by 0, and I want it in descending order, so I can say ascending is false. Let's see. No, it doesn't allow me. Sort values as a by. Okay, just a second. Okay, let me see what type it is. So type. It's a panda series. I can sort it. And okay, there is no name given to this. The problem is there is no name given to this. Okay. So if it is 0 or 1, okay, let me think. I can collect the values, but then I will lose these. Okay. Okay. I can do this. Okay. Let's say this is index. Okay. Let's say these are my actor names. It will just be tedious though. Okay. These are my, you can say, movies. Okay. So these are director names. Movies produced. This would be the values. And I can just make my own data frame for this. So let's call this as data, and this one is, let me just start like this. So these are my director names. Okay, and I'll say the column names are say name, and let's say this is data, and data of movies, num movies, and this would be this movies produced. Okay, looks like it. Okay, all right, makes sense. So this is your data right now. So for each director, I have the number of movies, and now I can sort it. Okay, data.sort values. You can say which column I want to sort it by num movies, and I want it in the descending order. Okay, so you can see Ridley Scott has one. M. Night Shyamalan is also there. This guy, I think, produced. I remember one movie. I think anybody who remembers what was the movie where this Dev Patel was, in a boat, and he kind of imagined that okay, there is a tiger in the river. Do you remember that movie? Does anyone remember that movie? I don't remember the movie name. Okay, also very famous movie. The guy who was there in Slumdog Millionaire. He had another movie who was directed by which was directed by this guy.
Life of a Pi.
I think Life of Pi. Yeah, I think that was the movie. Yeah. Okay, so let's see. Okay, what movies this guy Ridley Scott has created. So let's just see this. Okay, so this is Ridley Scott. Let's get all the movies from this Ridley Scott. So I need DFF titles. Okay. I only want the title. Okay. or maybe just let me get the whole thing. Yeah. So where BF of this director is equal to this, the Ridley Scott guy. Okay, and I will get all the things. Okay, so these are all the movies that he has directed. Am I getting it correctly? Yeah. Oh, sadly, is there Batman anywhere? No, there's no Batman anywhere. Okay, these are the movies that this guy has directed, and let's say if you just want the titles, these are all the titles. Okay, all right. Okay, I just want to confirm one more thing. Give me a sec. Okay, this M. Night Shyamalan. Sorry. One second. Okay, after sorting it, I want to get this second entry. So this is a data frame. I can get the second entry like this. Use integer location. I want the name of the actor, which was being this second location, column 0. First location, column 0. I need to reset the. I need to reset this. But anyways, this works fine for me. I just want to check this. Okay, I'm just curious. Was it Life of Pi or something? Okay. No, it's something else entirely. Maybe it's not here. Okay, maybe it's not here. Just give me a second. No, that's something else. Otherwise, you would see Dev Patel here somewhere. No, but this is the movie only, Life of Pi. I think, yeah, this guy was also there as the young. Okay. Let's see. Yeah, this is the movie. This is the movie. Okay. 1 second. Oh, sorry, this is another movie. I'm confused. This is Ang Lee, not M. Night Shyamalan. Okay. Anyways, these are the movies that this guy has created. Yeah, I have seen this movie only, The Last Airbender. Anyways, this is nice. Okay, so let's do the other method. So if you guys are getting bored, tell me, we'll do some other thing. Okay, so this is method 2, where the approach is, since we know that there is only one director, right? If you look at these directors, okay, there is only one director, okay, per column. Per row, there is only one director. So what was suggested was, let me get the unique values. Okay, so these are all the unique values. And for each unique value, I can essentially, instead of doing unique, I can directly do value counts. Okay, this would have been a simple solution. I've done the value counts. It's already sorted for me. And I would have picked this Ridley Scott right away. Okay. So let's say I want to get the top director. So I can simply say, give me the index of this value 0. The first index, okay, which would be Ridley Scott. This is the most celebrated actor. Okay, and this is how you can do it. Does this make sense?
Yes.
And this would be, let's say, sorted in descending order. Okay, let's plot the top, say 10. Okay, if you want to plot the top 10, what you can do is take the top 10. I need the top 10, so I will say .loc. I want the top 10. I would rather say, give me the top 10. There is nothing here, so I can just write it like this. Give me the top 10. And I want to plot it. The kind is, I want a bar plot. Okay. Okay. So these are the number of movies produced by these people. So. Okay, I think this would look better. Okay, this would look better. It's called as bar H, horizontal bar chart. This would look better. Okay, so that you can see the comparison also. Okay, so this is about the first one. Let's do the second task. Which task do you want to do next?
Multi-output classification.
Multi-output classification, predict the genre from the movie description. Okay, let's do
Yeah.
that. Okay, so we have to work with this description. So let's see. So these are my, I'll just make the task labeling. Okay, 1 second, I'll just copy paste this. What was the name of the task that we decided?
Multi-outputs classification.
Okay, let's see this. Here you'll have to do a little bit of pre-processing for the description. This would be new to you. Okay. See, can you see that descriptions are what we say? So first, let's deal with genres, the outputs. Okay, let's deal with genres, the outputs. Yeah, these are the outputs. Okay. So you can see that, okay, one movie has several genres. So what I'll be doing is I'll be creating, for each new genre, I'll be creating a column. Okay, for each new genre, I'll be creating a column. So let's create a column for each genre. So again, I can use this transaction encoder. That will be easier. So I have called this transaction encoder as TE. I'll just recall it again. And let me first fit onto this. Please note that the input is an array of lists. So I have to convert this to an array of lists. So use the string property and split it by comma. So I will just show you this. So use the string property, split it by comma, and it will give you 3 values in the first row. Okay. Do you see that?
Yes.
Is this clear? Okay. Maybe I'm going to do also this. Let's sci-fi I'm going to join. Okay. I'm not sure. It is quite possible in some cases sci-fi can be kept separately, but let's see. Some of these transaction encoders, like they also take hyphen to be as a delimiter. So they will also use comma and they will also use hyphen. I'm not sure. Some of them they do. Okay. So once this is fitted, I can see the unique columns. So these are the unique genres that I have. And let me just transform everything. So this was the data that we had. Okay, and so this would transform it. Again, I convert it to integer. Let's make a data frame out of this. So this is encoded. Let's call it genres data frame. And let's take this data and the column names will be te.columns. So this is your encoded genre data frame. Okay. I mean, in this case, we are safe. So sci-fi is in 1. Okay. So we have a total of 20 genres. Okay. So if the genre is present, it's a 1, otherwise it's a 0. Okay. So these will be my 20 outputs. Does that make sense?
Yes.
Okay. So now these will act as my 20 outputs. Okay. Let's try to process the input, which would be difficult. Let's see this. So let's see. Okay. This is important. Okay. This is description. Now, how do you like to process it? You tell me. What is it? So since, can you see that all of them are strings? They are paragraphs, right? Does that make sense? I'll show you maybe the first description. Okay. I'll show you the first description at this index 1. Okay. Let's see. You see that there are, words here. So what is it that I should do? I mean, what way I should encode the vectors? I have to do it in the same way, right? For every word, I have to make a column. Does it make sense? For every word, I have to make a column, right? Does it make sense or not?
Yes.
So let's say there is a word following. Because it is present here, I will have to say a 1. Do you want me to show presence absence? So presence absence we can do in the same way that I have done like this, okay? Or do you want me to count the frequency of the words?
Present absent.
Okay, so presence absence only.
Both, like,
Okay, we can do all these things. Okay, I can tell you even more advanced stuff. But for now, let's see. Okay, what do you want me to do? Do you want me to count the frequency, or do you want me to just
Present absence is fine. Then
presence absence is fine? Okay, let's do presence absence then. And okay, so if you just want to do presence absence, just repeat the following things. But you need to process it. You need to have it as a list. So see the following things. Okay, see the following things. I need to convert it as an array of lists. Okay. All right. So first thing that you have to see is I have to break it down into tokens. Okay. So I can break it down into tokens with the help of this, with the help of spaces. Do you see that? So each individual letter is separate, right? That is what I want.
yes.
Okay. Before even doing that, I will convert everything to lowercase, because otherwise, in that case, capital lowercase will be treated as different than lower capital, I mean, than lowercase a. Okay. So can you see that firstly it was capital A, and now I just lowered it and I changed the case of it, and now splitting the data. Okay. Do you want me to remove some of the unimportant words?
Yes.
yeah, the A and all those.
Okay, so let me just show you. There might be a lot of issues with this, so let's remove the stop words. Okay, and that's where NLTK comes in. So from this NLTK corpus, you have these stop words. Okay, that you can use. Okay, that you can use. So I'll show you the power of NLTK also. Maybe I want to show you this first. Okay, so when I'm splitting with this space, what do you think will happen to a word where the sentence ends? What do you think will happen to a word where the sentence ends? Any
One.
guesses? Look at this. Okay, there might be a dot appended to another one word. Do you see that?
Yeah,
So it's not doing a good job, right? I mean, if you tokenize it like this, it's not doing a good job, right? Do you see that? That is how we will manually tokenize it.
Yes.
So if there is a word universe and universe dot, they will be treated as differently, right?
Yes.
So it's not going to capture it. I'll show you the power of this NLTK. So NLTK also has a tokenization mechanism. So what you can do is from NLTK, you can import a mechanism. So this is just to show you the power. So I'm going to discuss a concept called as tokenization. Tokenization means breaking your data into parts. Okay, and these parts can be these parts are called as tokens. So you can essentially do two types. One is called as sentence tokenization. You can break your data into sentences, and the other one is called as word tokenization, where you can break it into words. Okay, so I'll show you maybe say the first part, which is sentence tokenization, and then we will do word tokenization. So from NLTK, you have to import sent tokenize. Okay. So import this tokenizer. Let's use this. And you can give it any sentence and it will break it nicely for you. Just to show you, I'm going to use this 0th sentence. Okay. Take a look at this. And it will separate the any special character separately. Okay. Sorry. I'm doing sentence tokenization. My bad. Let's first do on a description which has multiple sentences. Okay, 1 second. Let's see which one has multiple sentences. Do you see that this one had multiple sentences? I'll print the description also. Okay. Okay, do you see this? So this was the original description. It has tokenized the two sentences beautifully. Does it make sense?
Yes.
Okay. Now, how would you have done it? Like, let's say if you were to break the data into sentences, how would you have done it?
Using split, and in that split delimiter would be a full stop.
And let's see what's the problem with that.
It will not give a full stop with the sentence.
It will not give a full stop with the sentence.
Yes.
There will be three parts.
Yes.
One part would be this, another part would be this, and the third part would be this empty part. Does that make sense?
Yeah.
Okay, so that's a bad thing to do. Okay, do you see this? So it's giving you three parts essentially: one this, and one this. Okay. So and you can see it, right? It actually eliminates this extra space also, which is there after a dot.
Hmm.
Okay, so these are nice, you can say, functions written for you that you can use for tokenization. So let's say, okay, and you can say, okay, this is the sentence is tokenized using the default ones. Obviously, you can see, okay, NLTK one is better. Okay. Should I explain? All right, let's do word tokenization. This you would see, okay, this is even more better. So I'm going to print this again. So here the function is word tokenize. Okay, I want to focus on this. See, do you see dot is coming separately?
Yeah.
You see, the last dot is also coming separately. If you would have just done using spaces, I'll do that also. Also on this, so you can see 24th dot is coming here, personalities has a dot, and it doesn't do a good job. Does it make sense? It is always advised that, okay, you convert this string to lowercase first and then split it. Okay, because then otherwise capital letter words, and this here also you can, tokenize this string. Before tokenizing, you convert it to lower. Okay, is this clear?
Yes.
Okay, now I'm going to show you how to remove, let's say, the stop words. Okay, so let's focus on removing the stop words. So to get the stop words, so there is a list where you have the stop words. It's present in NLTK corpus. You get all the stop words from here. Now, NLTK supports various languages. Okay, since we are only interested in English, we will say, give me the stop words. Okay, it's called as give me the stop words of the words belonging to English language only, and this will return a list. Okay, these are all the stop words in the English language. Okay, all right. So these are all your stop words. Let's call them as SW. Okay, it's a list. I want to, do you see there are no special symbols like dot, exclamation mark, question mark, and all that? Maybe I would like to extend this a little. So I'm extending this with my own list. Maybe say comma. I don't want a comma in my text. Exclamation mark, maybe a dot.
A question mark.
Let's say a question mark. Okay, so let's do all this. Okay, just to ensure that we don't see any issues.
Understood.
A star, underscore,
Okay, all right.
hyphen,
Underscore. Okay, anything else? Maybe
a
this
hyphen.
hyphen I've already added.
Okay.
Okay, let's say colon. Okay, makes sense. So these things I'm extending. And if you look at stop words now, you would see at the end it would have been extended. Make sense?
Yes.
Okay, now I'm just going to do this. Okay, see this. So I have this tokens, right? Using this, I'll use this. I have these tokens. Okay. So these are all the tokens that I have. Okay. I'm going to simply run a for loop. See this carefully. So let's say for each word in this tokenize, okay, you can actually do list comprehension also, but I find this to be easy. Okay, I love writing the whole code. So what I can say is that if each word not in SW, can I say that I don't need to use it?
Yes.
Okay, and you can just print it if you just want to show, okay, what words have been eliminated. Or maybe I'll just make a new list. Let's call this list as, say, L. Okay, and I'll say just append to this L. So this will tell you what was the difference. Okay. So let's see how many words were there originally. Okay, so the number of words originally that were there were these many. So this was the original number. One bracket is missing maybe. Okay, 29. And when you look at L, how many got eliminated? 13. Okay, do you see this? It is eliminated dot, all that. If you want to eliminate numerals, you can add numerals and eliminate from that list as well. Does it make sense?
Yeah.
Okay, we will talk more about how to reduce from this list also, but not now. Okay, but not now. We'll do it maybe tomorrow.
So, like when we talk about numerals, you can see that 24th was there, right? If we were adding the numerals over there, it will only remove that 24 only, right?
No. It will not change anything.
Oh,
So
okay.
whatever is there in your list, right? The stopwords list, only that will be removed exactly.
Okay.
It will not touch it otherwise. Okay. See, that is why I said NLP is hard, because there are so many issues with it. Okay. So if you want to dig deeper, right? Pre-processing takes the most amount of time if you think about it.
So we can combine this with that regular expressions and
You can do it with a regular expression and then you can do this. Okay. But then in that case, you may sometimes eliminate important features also. So you have to be very careful. Okay, let's say there is a movie about Bond. Would you eliminate 007?
no.
It's you get the point, right? For movies, 007 is important. So, but when you're writing numerals, you will eliminate it, right? If you're using regular expressions.
Yes.
So that's a key thing there. So just wanted to highlight this fact. Okay. So let's say we have this list. So now I can, do the transaction encoder of this, right? Does it make sense? Now I can do the transaction encoder after removing the stopwords. Okay, this will be actually pretty big. Okay, but let's see. Okay, let's see. So I have this as my descriptions. Okay, let's see this carefully. So these are my descriptions. Okay, I'm going to use the lower property first, and then I am going to. So basically, for each of this. For each in this description. So I'm printing you say the descriptions. Okay, look at this. Yeah, sorry. So it's printing each description. For each description, what I will do the word tokenize. Okay, so word tokenize each. So once you tokenize this word description, let's call it as a tokens, and then I will run a simple for loop saying that for each word in tokens. Okay. I will say that if each word is the same thing that I did earlier, okay, it's not in your stopwords list. What I will do is I'll append, okay. So this is my data. Okay, second. So after I append it, I'll just create an empty list also here. And if each word is not in this SW, I'll just append it to this each word. Okay, and then once this is done, okay, I will append this list L to data. Does it make sense what I've done?
Yes.
Okay, so I've taken the description of each movie. I'm tokenizing it. It will give me the individual tokens of this first. So a group of intergalactic animals and so on. Okay. Then I'm traversing this. I get this A. I see that, okay, it is, if it is not there in this stopwords list, then it will get appended to L. If it was there, it will not. So A will definitely be removed because it's a stopword. Group will not be removed, so group will be appended to L. So L contains, for each, you can say for each description, L contains those tokens which are not stopwords. And once this whole thing is done, so basically once this whole thing is done, all the stopwords have been removed. I'm just appending this whole list of, you can say, non-stopwords to my data. Okay. So data will be like a list of lists. Does it make sense?
Yes.
Okay. So let's just run this. It's capital publication. Okay. So see this. Okay. Maybe this will give you an idea. Okay. So for every list, okay, for every list, this is the first list. Okay. This is the second list. So stopwords have been removed. Okay. This is the second list. So stopwords have been removed. Okay. All right. Now I'm going to, because I have to do simply presence or absence, right? So I can use this data on this transaction encoder. This will be quite big though. So let's fit it onto this data that I have. It's already as a list of lists, and I transform this as well. Okay, and I convert this to integer type. Okay, I put it into this data frame. I'm writing everything in one go. The same steps that we have discussed before. Column names will be the column's property. Okay, and that's it. We are done. Okay. Do you see that it has? We could have eliminated these words also. Yes or no?
Yeah.
Okay.
The dollar sign and everything.
So, I mean, you can do, so there are 5,964 features if you see carefully. So, I mean, you can try removing all of them, but let me keep it for now. Okay, let me keep it for now. So this is my encoded features, encoded description, let's say. And let's save it. So I know my input, I know my outputs. So I'm going to split it into two parts, train and test. Which algorithm do you want me to use? I'll show you on one only. Give me any algorithm that you want. One that should not take much time. Any classification algorithm, because everything is binary. You can use any algorithm. It could be multi-class also. There is no harm in that.
Maybe decision tree.
Okay, we'll use decision trees. No issues. So this is your data, input data. And where was your outputs? Here. So here we are predicting genres from descriptions. So let's specify the test size. Give a random state to ensure you and I get the same split. Get the data frames. Okay, so this is ready. And then now we can just train the model. So I'm going to use decision trees. For this type of data, I think you should use name base. But anyways, I'll use decision tree. This is your decision tree classifier. See, the benefit of doing multi-output modeling is this. See this. Okay, how many outputs do you think would be there in Y-train? Any guesses? Outputs I'm asking.
Genre, we have seen like sci-fi and all those.
Are there, right?
Yeah.
So do you see 20 genres are there?
Yes. The
Okay.
20 outputs.
20 outputs. So one good benefit is like if you take this decision tree classifier, okay. So essentially what it will be doing is it will be training 20 different decision trees. You can think of it like this. Let me call it say DTC. Okay. So I'm giving a random state here. I'm going to reduce the depth. Okay, we have a lot of features. Yeah, so this is just to show you, okay, you can actually do tuning at your own time. So I'm going to use the max depth as say 5 here. And let's fit the model onto your data. So there is no need of scaling as such because it's already binary. Everything is binary. And also for decision trees, you don't need to. So this is train, and now you can predict on the test set. This is the test set. These are the predictions. It's giving you 20 predictions. Okay, it's giving you 20 predictions. So what is it that you want? You want accuracy score?
Yes.
Okay. What type of accuracy score do you want? Like if only one matches or if all of them match? If only one matches or all of them match? Do you get the question? So imagine if you look at the first one, right? Okay, let's see the first one. Okay, this is the first one. So how many genres are actually predicted? One, right? One genre.
Yeah, yes.
Let's say in some of them, there might be multiple genres that will be predicted, hopefully. Hopefully, I'm not sure. Okay.
Mhm.
It's always giving one. Okay, it's always giving one. But there might be. Okay, there might be. Okay, let's see this. Okay. Let me just do this. Okay, for each and DTC.predict X test. Or I'll do this. Okay, this would be easier. Yeah, do you see this? So in some cases there are 3 genres predicted, and in some cases there are 2 genres
Two
predicted.
genres. Yeah, mostly
Makes sense,
three.
right?
Yep. Sorry, one.
Okay. So mostly, I mean, it is 1, but in some cases there are 2s as well, 3s as well. So how do you want to compute accuracy? So see, the actual values are this, right? Let's see. The actual values are this. Okay, I'll do the same thing across the actual values also. Okay. So if you look at the first one, which is a 3, by the way, let's print the values. Yeah. So if you look at the first one, out of these 3 genres, if this was not present, it is, I mean, no doubt incorrectly classified, right? But let's say if one of the genres match, would you want to count it as correct or incorrect?
Any one matches, yes.
Okay, so I mean, there are many ways to do it, right? So if you want just exact match, okay, you can do this. You already have the accuracy for it, right?
Can I do also like if out of 3 only 1 matches, so for that particular first row the accuracy score is 1 out of 3?
That you can also do. Okay, we will do that if you want, but that doesn't make sense, right? I mean, you can do that, but that doesn't make sense to me. Why? Because you have to give a value of 0 or 1 for a matching. Okay, you have to give 0 or 1 for a matching. See, what is accuracy? We say total number of matches divided by the total number, right? So the top part, the numerator part, is actually an indicator variable. It can only be a 0 or 1. But if you want a special metric, I understand what you're saying. We can do that also. I'll show you how that is done. You have to make your own metric. Okay. You have to make your own metric. We'll do that also. Just give me a sec. Okay, we'll do that part also. There is no harm in that though. But you cannot call it accuracy. Just that's what I'm saying. So this is accuracy score. This is exact matching. Okay. See, please note that our decision tree is just, I mean, up to 5 levels. I have not grown the tree to a significant levels. We have 5,000, almost 6,000 features. So it's very less, 4% only. Okay. So only 4% of the movies are matching, 4.33. Okay. Now let's see, at least one of the genres is matching. So what I'll do is this: for I in, say, a range of what was the DTC predict, right? Okay, let me call this as spreads instead of calling this, and this is too big. Okay. Sorry, did I save it? It's my bad. Just give me a moment, please. I need this. I'm saving this in predictions. Okay. So I'm looking at how many predictions are there. So there'll be almost 300 predictions. Okay. Similarly, so for each prediction, I have so for each prediction, I'll have again 20 values, right? Range of this I dot shape of 0. So there are 20 values in it. Okay. So what I have to do is I have to simply count the accuracy, right? So I mean, even if one of them matches, right? That's the whole point. So let's say my counter is 0. My counter is 0. So this will count how many times it is matching. Okay. For how many movies? It is matching. Okay. At least one match is there. Okay. For how many movies? At least one match is there. Okay. This is what I'm going to count in this counter. Okay. So, we are trying to find like at least one match. Okay. So I'm saying that, okay, if you are, give me a sec, let me think. So the first thing would be, so I will get this prediction array. Okay. I'm checking essentially if the spreads of I, sorry, this would be each spread. If each spread of, okay, this is not each spread, so this would be I of each spread. I will just say for this I and D in range. So I of each spread is equal to 1. See, also basically it is 1, and also just a second. We have to get the actual values which are in y-test. So y-test of this I is basically this is the movie number, okay, and this is the what we say is the genre number, okay. So we are saying that if y-test of I comma this I and D is equal to this I of I and D, then my job is done. Okay, I have found one match. So I will just say counter is equal to counter plus 1, and then I just break it because I need only one match. Does it make sense?
Yes.
Here. So what I'm doing is, see, I'm taking this first row. Okay, I'm taking this first row. I'm getting wherever there is a 1. I'm basically getting wherever there is a 1. Okay. So first I get this first row, then I see how many elements are there in this first row. Then I traverse them over one by one. So somewhere I'll see a 1, right? Which means that the predicted genre is 1. So wherever I see a 1, I say that, okay, this has to be a 1. And then I'm checking that in the predictions column, that thing also has to match. Okay, if that thing matches, then I'm saying that increase my counter. Otherwise, and whenever you see one match, just break it up. Okay. Okay, there is this int object has no, sorry, I just made a mistake here. This should be like this, my bad. For I int is dot shape of 0. So this is like the movie number, and then I'm saying for index and range of I dot shape of 0. Yeah, this makes sense. Wherever this, just a second. Give me a second. Now this has to be like this only. This will be. Okay. So the first, this would be I. I would be the whole thing. Now I would be an integer. So let me get preds of I. So this is the column number, and I'm getting the index from this. This has to be equal to 1, and y test of I comma ind. Yeah, it has to be equal to I of ind. Sorry, this has to be equal to this breadth of I of ind. You just made a mess out there. Give me a second. Okay. Which one doesn't have any shape? Okay, just a second. Okay, give me a sec, please. What spreads dot? Where is the spreads here, right? Is it not run? No, spreads dot shape of 0. Just a second. If this is spreads, it's the number of rows, right? This is fine. So I would be 0 here initially. And if I look at spreads of I, just a second, at what it is raising an error here. For I and D in range, I dot shape of 0. Oh, okay, got it. Here it is. Here the problem is spreads of I dot shape. Okay. So this is 0. This should be 20. Yeah. Okay, hopefully this works. There's still some issue. It says at 0, 6 at what? Let's try to okay, let's try to print. Okay, give me a sec. So let's print the spreads of I. So let's print spreads of I. Okay. Okay, it's printing all the predictions. Okay, that's fine. Okay. Then what I do is I get the indexes from this shape. So I will just spreads of. Okay, I'll just take this. Print spreads of this I. Okay, and so spreads of I would be this. So I'll just print the indexes. It should print 0 to 20, 0 to 19 essentially. Yeah, it prints 0 to 19 for everyone. Yeah, it prints 0 to 19 for everyone. Yeah, makes sense. Okay, this is correct. So it's raising an error here. Okay. So spreads of this I is the movie number. This is I, this is index. Okay, this is all right. If it is equal to 1 and then y test of I comma ind. Yeah, we print. Yeah, this is where the issue is. It says that 0, 6. Does anyone see any issue anywhere? It's throwing an error here. So this is one of the conditions, and this is another condition. Okay, maybe I'll do this. Okay, I'm not sure what's the problem. I guess. Am I writing? Am I making a mistake in writing an if clause? Can anybody confirm this? I don't think so. Y test of I comma ind, test of I comma ind. It looks all right to me. It's a problem. It's still giving me the error here. Prediction of I. Okay, let's see. Oh, I think I got it. I think there's a, yeah, I got it. I think spreads of this. You cannot access two things in NumPy array. I think that's the problem. Okay. Okay, this gives me the predictions of I. Okay, that is fine. And let's say if I just get this, I have to write it like this or what? Okay, if I do this, why is this not working? Oh, this is also working, right? But when I write it here, no, this is working fine. So it's, I'm just checking if I is equal to this. Okay. Anyways, this is, I'll do this. Okay. This is simply, is there a better way to do it? I can check the argmax of that number, and if that matches, no, then that would be incorrect. Anybody, you can help me out here. Can somebody tell me where I'm going wrong? Showing an error at this point. This is getting predicted correctly. So I'm checking if this index is 1. Okay. If this index is 1, and I'm also checking if the corresponding index in y-test, if this index is also 1, okay, I mean, basically, if this matches with the spreads of I and D, I can just increase my counter. That's where it throws another, I don't know why. Sorry. Use the same syntax for this. Both the things are giving you the same thing, but doesn't work here. Okay, just a second. I think I can do it. Maybe there is a problem the way I'm accessing these NumPy arrays. Let's do this. Okay, these are all the predictions. Has to be NumPy array. Yeah. Looks all right to me. Okay, these are your predictions. Oh. That angles. Hopefully, this will be done this time. Come on. Oh my goodness. Got it. This is so bugging. See, y-test is our data frame. That was the issue. I was thinking like, what's the problem? Even that code was correct. I just didn't realize that whitest was a data frame. Okay, so this is your counter. Okay, and if you want to see the accuracy, so this would be counter divided by whitest of. So much time wasted because incompatible formats. Okay, so it's 53% are matching with at least one. Are you guys still there?
Yeah.
The only problem was like whitest was a data frame and that threads is a NumPy array. So while I was accessing this, it was actually going to that particular value and trying to access it. Okay, so that was the problem. So what I'm doing right now is I'm checking if you look at this prediction, right? So if wherever there is a 1, okay, I am checking if in the whitest, if there is a 1, wherever you see a 1, you stop because 1 has matched. And out of the how many movies are there in whitest? I think 300 movies are there in whitest. Okay, so out of these 300 movies, at least for 53% of them, one of the you can say one of the genres is matching. Okay, at least one of the genres is matching. Okay, so this is how you can do it. Now, what Shilpa suggested, what we can do is we can actually count. Okay, like per movie. Okay, we can count per movie. So I'll show you. See, I'm not going to sum it up. I'm going to only create maybe say a NumPy array. Okay, and let's create it for this much size. And initially everything is 0. So basically, I'm storing the what you are saying is the per genre percentage, right? How much percentage is matching? Okay, let's call it per match. Okay, per movie match. Okay. Okay, so these are 300 values, currently zeros. I am saying that okay, if this is matching, okay, I take my counter. So this is the movie number, right? Okay. So I set counter to 0 here. Okay, and I say that okay, if this is matching, what I say counter increases. So okay, let's see. I have to do 2 variables, counter and total. Okay, or I can simply do this. Okay, I'll get the counter and I increase it by 1. I'm not going to break it. So basically, for each movie, it counts. Okay, and after all, I've counted. Okay, how many are matching? I have to. So this would be here. Okay, after I've figured out. Okay, there is a match. I have to compute this value counter divided by how many ones are there. So how many ones will be there? Will be in here. Whitest of the actual genres, which are ones. So whitest dot values of this, because we are running for this movie I, we can just sum it up. So this would be the fraction that we are matching. And let's say this fraction is appended to this per movie match. Okay, this fraction is appended to per movie match. Okay. And I'll say this is like, okay, so this is per movie, how many genres are matching? Okay, the fraction of it. Okay, per movie, the fractions of the genres are matching. Genres that are matching. Okay, let's see. I'll just print this per movie match here. Okay, so you see that, okay, in the first case, 0.33 is matching. Shall I show you the results also, like side by side, so you can confirm, oh, okay, one of them is matching?
Yes.
Okay, let's see this. This is the first one, the actual movies. Okay, sorry, I'll just show you the first one with integer locations. So let's get the first one, or maybe let's use LOC. Whitest of this. ILOC would be nice. Okay. Okay, let's say the values. Maybe the values. Okay, these are the values, and this is your predictions of 0. Okay. Do you see that only one of them is matching?
Yes.
Okay, so you can see that it comes out to be. So how many are there? 3. If you see there are 3 ones. Okay, out of these 3 ones, how many are matching? One of them.
Only one. Yeah.
That is 0.33. Does it make sense?
Yes.
Okay. Let's look at the second one. Okay. Maybe say I'm just picking a random one, which is third one. Okay. At index 3, the fourth basically. Okay. How many of them are matching? It's still one.
One.
Okay. Out of 3. So it is fourth one. Look at the fourth one. It should be 0.33. Which index it is? If this is computed incorrectly, right? Then just a second. This is computed incorrectly in that case. How can this be different? The fourth one, this should be 0, 1,
Zero.
3, 4. This should be 0.
Yes.
But it seems like, okay, they are matching, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. I mean, they are matching. Yes, I should. They are matching. What's the issue? For just a second. 1, 2, 3, 4, 5, 6, 7. It says the seventh, they don't match. Or is it the eighth one? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. No, they are matching, right? Why is it saying this is false? Sorry, this is true, right? 2, 2, 4, 2, 6. It says seventh is false. This is the seventh index, right? I mean, seventh value.
Yes.
It seems that, I mean, are they not matching? I mean, it appears to me that they are matching, right?
It's the seventh
Yeah,
value.
right?
Both are one. Yeah.
Even the 0th and the first index, it should be true both.
True, right? I mean, it's not matching. What is the problem with NumPy in this? Okay, so what's the difference here? Okay, just a second. Okay, all right. 0, 0 should match. This is strange. Anybody who has an answer for it? Anybody who has an answer for it? See, for the first one, it was doing this correct job. Okay, let's see again. For the first one, it was doing its correct job. Okay. So the seventh place that you see over here. 1, 2, 3, 4, 5, 6, 7. So this is a true. It's doing a correct job here. Okay, let's go for the third one. This is strange even for me. Okay. One, two, three, four, five, six. It says a false.
Is on the one. It says.
We cannot run it. Oh, I think I didn't run it. My bad. I didn't run that at that time. Okay, see, there is zero match. My bad, there is zero match. Sorry, I didn't run it. I just ran this part. It was the previous one only. Okay, but let's take anyone else. The code is correct. I didn't run it at that time. Okay, it's my fault. Tell me any other. Okay, let's say
Fifth
5.
index. Yeah.
Let's say 5th index. Okay. So this is 5th. See, I didn't run it. I still didn't run it. If you see. Okay, let's see this. Come on. Now see, okay, there is a one match happening, right? At the 5th index.
Yes.
Okay, and let's run this. Okay. This should be correct. This should be correct. Look at the 5th index. 1, 2, 3, 4, 5. It's a true, right?
Yeah.
Okay. So if you look at the 5th index, it's a 1. There's only one, right?
Yes.
Yes, it's a 1. Okay. Let's take any other index. Shall I take the last one?
Okay.
Yeah, I'm just taking the last one. This is the last value. Is there any match? No, right? Last one is 0. So the code is correct. The code is correct. I didn't run it at that moment. That was my fault. Okay. You can see that there is no match here. Here and here. No match. Okay. All right. Okay. Which task do you want me to do next? Where are the set of tasks? Here. What is the next task?
Who are the most celebrated actors?
Okay, the most celebrated actors.
Yeah.
Okay, so these are your actors. Okay, again, you have to encode it with transaction encoder. Okay. So let's encode it. Okay, it's already separated by commas, but you have to convert it to a list. Okay, so I'm going to convert it to a list.
As we were labeling it as task, like
Yeah, I'll label it as task also.
three. Finding the most celebrated actor.
Yeah. Okay, let's see this. So let's transform this data. This is what happens when you don't wash your face. All right. This is integers. Okay. Let's convert this to actors data frame now. Actors data frame. This is the actors data frame. Let's find the most celebrated actors. So I'm going to do the sum of this along the columns. Okay.
Axis.
Okay. And once the sum is done, I can again you have to do this, okay, because it's not allowing me to sort. Okay, let's see. Okay, let's see. I think it will be if I just say ascending is false. Yeah, it does. I don't have to specify the column because there is just one column. Okay, so Christian Bale is the one, the guy who acted in Batman and a few other movies like Psycho. I don't know. It's called a Psycho something. Let's see what are those movies where this guy Christian Bale has acted. So I'm looking at the first most celebrated actor. Okay, I'll just do it like
Christian Bale.
next line. Okay, I'll do it in the next line. American Psycho was the movie. All right. That's the most celebrated actor. Okay. Now I have to see in this data frame wherever this Christian Bale is. Okay. So in my actors.data frame, okay, wherever this guy is, Christian Bale, okay, this would give me my Christian Bale, okay, and I have to see wherever this is equal to 1, right? Does that make sense?
Yeah.
Okay. So this is my condition essentially, and I can do actors.data frame. This will give me the indexes where this is 1, okay. So what's the problem? Sorry. So this was my condition, okay, that whether this is true or false. So I need to get the indexes of only those values where it is true essentially. So I will go to my original data frame. Wherever there is a true, I'll do that. My original data frame was called as what? DF. So I'm taking all those values where it is true. So this is where all the movies were there, where there is Christian Bale. You can see that.
Yes.
There's Christian Bale. And if you just want the movie titles, you can just write title in front.
Title.
Okay. So these are all the movies. Now you may know some of them already. Okay. And let's say you want to print the year also, like which year it came. So okay. So all right. Okay. Anything else? Okay. Which is the next task that you want to do?
Based on the movie characters.
Okay, the second one, regression
Yeah.
tasks.
Yes, the regression one.
Yeah. So this is your task 4.
Task 4.
Okay. Okay. So we have what movie characteristics do you want me to take? There are many, right?
Yeah.
So let's limit ourselves. Okay, what movie characteristics do you want me to take? One, the genre. Genre would be important, right? Because genre decides like how many people are watching the movie. Okay, so there is this one genre. Okay, what else? I think one second. I have to see what did I call it? I called it, I think, encoder genre data frame. Yeah. Okay, what else? Descriptions I'm ignoring. Okay, descriptions I'm ignoring. Can I take actor, directors?
Okay.
Okay, so I just did actors. Okay, what did I call it? Actors underscore DF.
Actors, yes.
Okay, and I did these directors also. What did I call the directors? Encoded directors data frame. Are these 3 sufficient, or let's take something else? Year shall I take?
Actors. Yeah. Okay.
Okay, let's take year also. So I'll just encode years. So you can just encode years directly like this. So this is a function available in pandas, which you can use to directly encode this year. Okay. All right. So let's say this is year data frame. Okay. Let's take CA data frame. Anything else?
That's it.
That's it.
Yeah.
Okay. And I'm going to predict this runtime rating and metascore. Okay. Or maybe revenue. I can do all things if you want. I'll take runtime also because runtime is also an important feature.
Yeah, runtime rating,
So
revenue.
DF of this runtime. Okay, what is this column name? Give me a second, please. It contains spaces, so I have to see. Columns of 6 years, 7 years, and 6 year runtime. Okay. After basically concatenate all of them. Okay, I have to merge all of them. So I think you can do it by, in pandas there is concat. Okay, you can concat it along this axis 1. Oh, sorry, axis 0. 1 second.
TF dot column 7 columns.
Oh, sorry, I put it in quotes. My bad. Okay, what's the problem right now? Oh, sorry. Okay, makes sense. So all of these has been put into a single, what we say is row vector. 1,000 movies. For each movie, you have first the genres, then you have years, and there are a few things in between. I think directors are there. What did we take? So first genres, then actors, then directors, then year, okay, and then the runtime. Does it make sense?
Yes.
Okay, I just want to see, okay, the shape of everything so that I can, I know I'm doing correctly, okay. Yeah, I'm going to print the shape of everything. Let me print the shape of. So +1 would be for runtime. So 20 plus 2394. Oh, actors are too many. That I was wondering like why it is 3070. Actors are too many. So 20 plus 2394. I mean, essentially we can do this. Yeah. Shape of 1 is this. I just want to see, okay, if we are doing everything correctly. Okay, +1. Yeah, we are getting this correct. Okay. All right. So this is my total data frame. Okay, let's say my input. So my input is ready, and now you can train the model. Which model do you want me to train? Which model shall we train?
We'll take the same.
Same, but now it's regression. So shall I take decision tree regressor?
Okay.
Or anything else that you want? I mean, I can take anything. What do you recommend? Okay, I'll take this only. I'll just limit the depth. Let's limit the depth. Because the number of features are big, I'm going up to max at 20. Second. And the outputs are, that is what I have to see. What are the outputs? So shall I predict the last 4 values? 1, 2, 3, 4, last 4 values?
Okay, rating vote.
Okay,
revenue.
so let's say df dot shape of this one. Okay. We probably need the last four, right? Okay. Rating onwards. So inputs is INP, which is a concatenated data frame. These are the last four columns that I'm predicting. So starting from, we need to essentially fill NAs. Do you see that? Do you see that we need to fill NAs? There are some nouns here, right?
Yeah.
The movie data is not available. What should we fill it by? Shall I fill it by the mean? Shall I fill it by the mean?
Yeah.
Okay.
You dot fill now.
Okay. Okay, we have, I'm fitting the model onto this now. Okay, the model is fit. Let's predict. These are the predictions. What is it that you want me to compute? Which evaluation metric? This is a regression task. Which evaluation metric shall we choose?
Accuracy.
No, regression metric.
Okay.
These are regression metrics, all of them. You can use mean absolute error, mean squared, R2. Which one would you prefer?
Mean absolute.
Yeah. Pass the actual values, pass the predicted values. It gives you four values now. For each output, it will give you four values. One output corresponding to four values. Four outputs corresponding to the four columns. It's giving me across all of it. Okay, just a second. I think I can do it. I can provide the access also, I think. Is access 0 or access 1? It doesn't have access. Okay, maybe I'll do it like this. Okay, so y test of this, give me all rows, column 0. Threads of all rows, column 0. I just have to check, okay, what is y test? Give me a sec. Okay, just give me a second. Okay, if this is this, if I pass the values, it doesn't give me the four values. Okay, that gives me one value only. Okay, anyways, that's fine. So I can do y test of 0. Give me the integer locations. Take all rows, this column 0. Take values from it, and this is spreads of 0. So this is the MAE for ratings. Okay. One second. So this is the MAE for ratings. Okay. So on an average, it is doing an error of 0.772, 0.7. Okay. Let's do the average of for votes. Okay, mean absolute error for votes. So this would be for 1. This should be for 1. Okay. So by 96,000 votes, by almost 1 lakh votes, it differs. Okay. So it's doing very well on ratings. The next part was what? Revenue. Yeah. Okay, so revenue is around $69 million. If it's in $1 million, I don't know. And then this is the Metascore.
Metascore.
So this is your Metascore. All right, so this task is also completed. Any task which is remaining?
5 tasks we have chosen, I think. The
6 are there.
One.
Which genre is rated highly in terms of profit? Okay. This is just a data science activity, I think. So this is task 6, or is it 5?
5, I think.
5, okay.
Yeah.
I think I didn't label the first one. I didn't say number for that. Okay, anyways, this is fine. So to do this, I think we have this genre data frame. It's encoded genre data frame, I think. Yeah. So, and we also have this, what was the name for it? Revenue. df of df dot columns of 7. This was the revenue, right? What was it? It's runtime, sorry. 8 is rating, 9 is votes, 10 is, okay, this is the one.
Revenues in millions.
It's in millions of dollars. Okay, so this is the revenue for every movie. Okay. All right, so I have to figure it out, okay, which genre is rated highly in terms of the profit. So for each genre, basically I have to group it by. Okay, for each genre, I have to group it by. So it's like doing this, you have to, I mean, can I group it by genres? No, because here you have to group it by each genre separately and then you have to figure it out. You need to run a little bit of data analysis, okay? So maybe I'll do it like this, okay, see this. For each genre in this encoded genre.data frame, okay, let me print each genre. So these will be the column names. Let me print each genre. This is just to show you, okay, these are each of your genres. So for each genre, what I have to do is I have to take this encoded genre, okay, data frame, and I have to take a particular column. Let's say this is each genre, and in this, for each genre, I have to see where it is a 1. Okay, where it is a 1. Okay, so if I see that, okay, it is a 1, so let me put it like this. Okay, so I'm going to make a data frame. Let's see this. I'm going to make a data frame where the indexes would be, okay, let's see what will be the values. So let's call these as vals, and the indexes would be the movie names. So which would be this encoded, the genre name, sorry, encoded genre of df.columns. These would be my indexes, and my column name I'm going to give you, say, the revenue, the total revenue. Okay, the total revenue of a genre. This would be total revenue for a genre. Okay, and after that I'll sort it. I'm trying to get the vals. Okay, so this vals is empty right now. Okay, so if this is a 1, so this is, I'm trying to get, so let's say wherever this action is a 1, okay, wherever this action is a 1, so this would, where the action would be a 1. So this would be for data frame, wherever this would be a 1, the action is a 1. I have to basically go to its 10th column. What is the 10th column name? Revenue millions. So I go to its 10th column name, df.columns of 10, and I have to do the sum of it. Okay, so this will give me only those values. So just to show you, okay, I'll just print it. Okay, I'll do it for each genre so you can see this. Okay, I'll print the genre, each genre, and this. Okay. Okay, let's see this. So for each genre, it's telling you that, okay, the action genre is there. So at 0th movie, it has the action genre and the revenue is this much. The 4th movie is also action genre and the revenue is this much. 5th movie is also action genre and the revenue is this much. Does it make sense?
Yeah.
So it's doing for every genre essentially. Okay. So I'm just going to do the sum of this. So which will give me the sum of each genre. Okay, see this? Does it make sense? So for each genre, I have the sum. Okay, and I'm going to store the sum in this vals. Okay, let me store the sum in this vals. Okay. Okay, I've stored the sum in the vals. Oh, sorry, I should have appended it. And now, once the vals are appended, I'll just put vals here. Okay, see this. Okay, so for each genre, it tells me nicely like what are the revenues, and I can just sort it.
Sort it. Yeah.
Okay, by this, what is the column name? Total revenue. And say ascending is false. Okay, so adventure is something which is highly appreciated, then action and so on. Okay, so this is your what we say is the highly celebrated genres, okay, or the most watched genres, or earning the most revenue. If you think of anything that we should do in the last 8 minutes, we can do that also. So this was like a simple intro to your NLP. We will see, okay, how to reduce the features, because NLP has a problem with the number of features that you are generating. So we'll see that tomorrow.
Sure, Sat.
I'll also show you how to count each value. So if you look at the descriptions, a single word can be repeated many times, right?
Yes.
Instead of simply looking at presence or absence, we will see the count of each word. And then we discussed that, okay, the count of stop words would be enormous, right? If you think about it in comparison to other words.
Yeah.
So think of a word like the will be repeated the most time in general.
Yeah.
So what we will do is, if a word is repeated more number of times in most of the documents, that is likely to be a stop word. So we will normalize the importance of that word, the frequency of that word, with some formula by looking at across all the documents. So if it occurs in more documents, we will try to lower the frequency value for it. We will normalize that frequency value. Okay.
So that is only for the stop words or for every words? Like, for example, like.
See, because we don't know if a word is a stop word or not, right?
Okay.
So we will do it for every word. See, so the set of stop words that I have are a complete set of stop words now, right?
Yes.
So I might also see a lot of stop words once I generate my tokens. But if I miss, let's say by chance, if I forget about eliminating some of the stop words, they will get high importance.
Yes.
I don't want that to happen. So I will normalize the, you can say, the frequency for every word.
Okay, so you're saying that, for example, if the group, the word group was repeating in all the documents, I'll just take that as a stop word and then I'll eliminate it.
I will just put the frequency as 0.
Okay.
Instead of actually counting how many times group is repeated. If it is repeated across every document, it doesn't make sense to include it, right? If you think about it. What should be a feature? A feature should be something that is present in some and missing in some, right? If it is present in all of them, it is not informative. That is why stop words are not informative.
Okay.
Right? Because they are likely to be present in most of them, right? A and the, or, like if you think about these words, they don't really contribute. Why? Because they are present across all.
True.
You're thinking of, I know, from the English perspective, but from mathematical perspective, you think of it like this. If a word is repeated an enormous number of times, or if it is available in abundance, it's likely to be not a good feature. Okay, it's likely to be not a good feature. Okay.
Sure. Okay.
All right. Any other questions that you want me to do? We still have 5 minutes. We can do that. Anything comes to mind, like data science analysis or anything that we could do? I'm sorry, it took a lot of time because it was, see, that is what happens like if you don't come up with pre-prepared notebooks. It was a silly mistake from my side. Actually, one was a data frame and the other one was a NumPy array. Okay. So while I was trying to access the I, jth column, it was not present in that data frame. I was not even present. Because if you directly write, say, so let's say if I split it into train and test, in the test set, if there is no, say, 0th row, so if you write df of 0 comma something, it will throw an error. But for a numpy array, it will take the first row. Yes or no?
Yes.
Okay, that was the problem that was being created there. So I was like so flabbergasted. Okay, why this is happening? Because the code looked, I changed the code and then I realized, okay, no, it was due to the data frame. Okay. Anything else that comes to mind?
Yeah. Which genre gets more Metascore?
Which one gets more Metascore? It's just the
Yeah.
same thing. What we'll do is like this. Okay. It's the same thing. Let's run this here. The Metascore would be the last column. Just make it like this. So these are the Metascores. Okay. But why is this Metascore? Is there a fraction in some Metascores?
No, they're all
Doesn't seem like from here, but
yeah. But I'm not sure about the full data frame for the 1,000 rows.
okay, just a second. There might be, otherwise these values will not come. There might be, otherwise these values will not come. Okay, because we are doing everything correctly here, as far as I can see. Okay. Do you want me to print these values and check for the Metascores? Okay, let's see.
Yeah. Or JNTF of Metascore.
See, there are, right?
Yeah.
There are. Okay. Otherwise, this would not be the case. And then you can just put it here like this. So this would be your Metascore. I think I put it in vals again. This is total meta. You can do average meta also. So drama is the one. So people appreciate more dramas.
Dramas, okay.
I mean, they rate more dramas. It's not that Metascore would be high. Metascore is actually, I think,
It's kind of a TRP or something.
yes, I think what reception it is getting. Like how many people are attracted to it. The traction it gets. So how many people are actually searching for it.
Get it. Yeah.
So drama is something that everyone, I mean, it's actually twice if you think about it. But it doesn't
Drama actually.
revenue.
The revenue is less, I think.
Revenue is less for drama. I mean, if you see this, it's actually the seventh list.
Seventh less.
Seventh.
The action was the first one.
Yeah, but action is also something which everyone appreciates.
Second
one, okay.
one.
Yeah. All right. Okay, so I'll stop here. We'll meet, say, in the next class tomorrow, and then we will see the nuances of NLP using this NLTK package. We'll build a lot of applications. So whenever you come across any application, you have the hands-on to do this. Okay. All right, so I'll stop here. Any other questions from anyone?
No, Saturn from my side.
Yeah, I'll just upload this.
And you said you'll be uploading the data set also, right?
Yes, I'll do that as well. You just wait for maybe a minute. You'll have it. Okay.
Sure. And Saturn, for creating a resume, like, do you have any website or any app that you could recommend?
I'm forgetting the name. I created mine long back using some website like 5 years ago. I don't remember the name for it, but
because GUI people was recommended something, but
I use this template. Okay, I have it like this.
Okay.
But I don't. I mean, I prefer a simple CV. Okay, not like this.
Like more pages and
No, one page only.
Mhm.
Just put description. That's it.
Okay.
If you give it more pages, I don't think
Nobody has a time.
yeah, no, nobody has the time for it. Also, I think nowadays people are using what we say is, I mean, there are a lot of applications, right?
Yes.
So which manually scrutinize through a set of resumes. So I will say that, okay, use just a one pager. Don't use more than one pages. I mean, you can get, you just browse through LinkedIn and probably you'll get so many CVs. Just pick one and put your details in that CV.
Okay. Because I've created one, but I was not that much confident about that CV, so that's what I've asked.
Templates, there is, I would say there is no template as such, but it should have like minimal graphics.
Okay.
Minimal graphics, okay. It should have like more technical content, but minimal graphics. I've uploaded the dataset also.
Sure.
All right, people, take care. Bye bye.
Bye, Santa.
Just a second. Bye, everyone. Uploaded here. Bye, everyone.